Hello everybody. Let's quickly discuss a geometry question. Okay, we're given a right angle triangle OAB, and AB is perpendicular to BP, as you can see right here, and these two angles, they're equal. And what we're also given is that the area of triangle OAB is equal to the area of triangle BPQ, and both of those areas are 1. Okay, like this. What we need to do is we need to find the area of triangle BAP. Okay, we need to find the area of triangle BAP. Now this is the original question. To solve this question, we're going to introduce a coordinate system, as you can see on this side. Okay, we're going to take the origin at O. We take the positive x-axis along OA, and we're going to take the positive y-axis along OB or OQ, like this. Okay, and we need the area of triangle BAP. So triangle BAP is basically half times BP times AB. Okay, AB. So all we need to do is find the length of BP, find the length of AB. All right. To do this, let's suppose that OA is A, so that the coordinates of A are A0, and OB as B, so that the coordinates of B are 0, B, like this. So using Pythagoras theorem or simply the distance formula, we can find that this hypotenuse is square root of A square plus B square. So what we've done is that 1 by 2 times BP as it is. Okay, AB means square root of A square plus B square. All right. Okay, that's what we're going to do. Next, let's see. We need BP, right? We have coordinates of B, but we do not have the coordinates of P. In order to find the coordinates of P, we need to solve the equations representing the lines AQ and BP. For this, we need the equations for AQ and BP. And to find the equations of AQ and BP, we need their slopes. Okay, we need their slopes. Now let's see. This angle is alpha. So let's see, this angle, this is 90, this is alpha, so this is 90 degrees minus alpha. All right, 90 degrees minus alpha. And since this is 90 degrees minus alpha, and this is alpha, sum of exterior angle is this. The exterior angle is the sum of opposite interior angles. So we're going to get this angle to be 90 degrees minus 2 alpha. Okay, 90 degrees minus 2 alpha. So since this is 90 degrees minus 2 alpha, let's take a look at the big right angle triangle. This is 90 minus 2 alpha. This is 90. So this entire angle is 2 alpha. But we are given that this angle is alpha. So since the entire angle is 2 alpha, this angle will be alpha. Okay, all right. Now let's see. Tan alpha. We'll require this value will be required. Okay, tan alpha means b over a, like this. Now we need the coordinates of p, right? We need the coordinates of p. For the coordinates of p, for the coordinates of p, we need the equations of BP and AQ. Oh God! Tan alpha is b over a, and to find the length of BP, we already have the coordinates of B, and we require the coordinates of P so that we can use distance formula. So we're going to need the equations for AQ and BP. Okay, now let's see, the slope for, let's extend this a little bit. For the slope of, we'll extend it later, alright. Let's see, this is alpha, right? And as a result, this angle right here, this angle is twice alpha. But for slope, we need the vectorial angle, okay? Angle between two vectors. And for that, we need to give it direction on AQ in the increasing direction of x. As x increases, the value decreases. So this is the required direction, okay? This is the required direction. So the angle between this vector and x-axis, this vector, is this much. Alright, this vector, and this vector is this much. This is, the magnitude is 2 alpha. So since this is since this is in clockwise direction, the angle is minus twice alpha. Okay, minus twice alpha. So slope of AQ is equal to tan, this angle is minus 2 alpha, so minus 2 alpha, which is equal to minus tan 2 alpha, which means this is minus twice tan alpha, and 1 minus tan square alpha. Minus twice tan alpha means b over a all over 1 minus b over a squared. Alright? Now let's simplify this a little bit. Twice b over a all over a squared minus b squared times, what do we have here? A squared. So cancelling these out, we get minus twice b a over a squared minus b squared. Alright? So equation of AQ. What is the equation of AQ? Equation of AQ is y minus something times the slope is minus twice AB over a squared minus b squared, alright, times x minus something. So we can see that the line AQ passes through the point A, and the coordinates of A are A and 0. So minus A, and here we have 0. So the equation is y equals minus twice AB over a squared minus b squared x minus a. Alright, this is what we have. Next, so this is the equation of AB. Now for the timing, let's find the coordinates of Q. For the coordinates of Q, what we need to do is the coordinates of Q, we're gonna put x equal to 0 and therefore obtain y equals twice a squared b over a squared minus b squared. Okay, we're gonna need this later on. So the coordinates of Q are 0 twice a squared b over a squared minus b squared. Alright, the coordinates of Q are this much. Okay, so this is the coordinate of, this is the equation of AQ. Now what we need is the equation of BP. Now for the equation of BP, proceeding as before, we assign a direction like this. Okay, now we're going to extend something. Now we're going to extend AB like this, AB like this, okay, like this. And what do we have? The angle between this and this angle is alpha. Okay, this angle is alpha. But let's see, uh, between this direction, the direction on AB which corresponds to the increasing direction of x, okay, this is the direction, and the positive x-axis is alpha, okay, geometrical angle is alpha. Now but for the slope we need what do you call it, the vectorial angle. Since this is in clockwise direction, the angle is minus alpha. So slope of AB equals tan minus alpha minus tan alpha minus b over a. So the slope of BP is equal to minus 1 over slope of AB, okay, slope of AB, which is equal to 1 over minus b over a, which is equal to a over b. All right, this is it, a over b. So the equation of BP is y minus, since this passes through the point 0b, y minus b is equal to y minus b is equal to the slope a by b, a over a by b, times x minus 0 means x. So this is y equals to a by b plus x minus, a by b times x plus b. Alright, now we have the equation of AP and we have the equation of BP. So we can find the coordinates of what you call we can find the coordinates of P by solving these two equations. Alright, so we can equate the right hand side to obtain something like this, minus twice AB over a squared minus b squared x minus a. Alright, what we can do is ax plus b squared over b equals minus twice ab, a squared minus b squared x minus a. We can cross multiply and obtain a squared minus b squared ax plus b, okay, equals minus twice ab times b means squared x minus a. Okay, let's do this. A cube x plus a squared b minus ab squared x minus b cubed. Alright, let's see, minus twice ab squared x plus twice a squared b squared. Right. Oh, ax times b squared. So b squared. Ax times b squared means this will be b raised to the power 4. Now let's take all the x's to one side and all the constant terms to the other side. Then we get a cubed x plus twice ab squared x minus ab squared means ab squared x equals Now this a squared b squared, okay, a squared b squared, since I made a mistake right here, a squared b squared, we have twice a squared b squared, and this a squared b squared, if we take this to this side, we get a squared plus b squared, sorry, a squared b squared plus b raised to the power 4. So a common, a squared plus b squared times x is equal to b squared a squared plus b squared. We can cancel these two out, and we can say that x is equal to b squared over a. So the x coordinates of p are b squared over a. And for the y coordinates, let's simply put this value here. What are we going to get? A by b times b squared over a plus b. We can cancel out the a's. We can cancel out 1b. b plus b means twice b. Alright? This is twice b. Alright. We got this. Okay? Now, since we have the coordinates of p as well as the... Just a second, please. Now, since we have the coordinates of b as well as p, we can find bp as square root of b squared minus a, b squared by a minus 0 whole squared. So this is b4 over a squared plus twice b minus twice b. Okay, twice b minus b means b squared. So what do we have here? Square root of a squared b squared plus b raised to the power 4 all over a. Okay, and if we take this out, what are we going to get? What are we going to get? We're going to get b square root of a squared plus b squared all over a. All right, like this. And if we take, okay, that's what we're gonna take. We're gonna cancel out something else from here. All right, that's what we're gonna take. Now let's half times bp means b over a squared plus b squared times a squared plus b squared is basically a squared plus b squared. Okay, now we're going to take a squared as a common factor. Then we're going to get b times a squared over a means a, and 1 plus b squared over a squared. So this is the area of triangle BAP. Now if you look carefully, what we can do is, this triangle had an area of 1, so half times a times b will be equal to 1. So this part right here, this is equal to 1, and therefore the area of triangle BAP will be equal to this much, which is 1 over 1 plus b over a squared. Alright? Okay. Now, the area of this triangle is also equal to 1, which means if we drop a perpendicular BP dash like this, then triangle BPQ will be equal to PP dash times half times, oh god, okay, triangle BPQ equals half times PP dash times BQ, which is half times PP dash, means this is the x coordinate. Okay, this will be equal to x coordinate like this. If we drop a perpendicular from here, this will be x coordinate, b squared over a, so this and this will be equal. That's why PP dash is b squared over a times BQ. Now BQ is basically, how much is BQ? Twice a squared b over a squared minus b squared minus b. Okay, this is it. Now 1 by 2 b squared over a times, what we can do, we can divide this part as twice. Okay, twice. We can divide both the numerator and denominator by a squared, since we need the value of b over a squared. Okay, 1 minus b over a whole squared minus b. This is what we are going to get. Now if we take this b as a common factor, we will get 2 over 1 minus b over a squared minus b. Sorry, minus 1. And this is what we're going to get. Alright. Now, we know that this triangle is equal to this triangle in terms of area. So, this whole thing right here is equal to half times a times b. Half times a times b will be equal to half times b cube over a times twice 1 minus b over a squared minus 1, and we can cancel out these two halves, be like this. Alright, be like this, and what we can do is we can send this a down all the way down here, and we get 1 equals b squared over a squared times, to simplify this part, we're going to get something like this, twice minus 1 plus b over a squared. We need the value of this thing right here. Okay, now this will give us, if we take this part to the left hand side, 1 minus b over a squared is equal to b over a squared, b over a squared times 1 plus b over a squared, something like this. Okay, something like this. This means 1 minus b over a squared is equal to b over a squared plus b over a raised to the power 4. This means raised to the power 4 plus twice b over a squared is equal to 1. A squared plus twice a. Now if we use something like this, b over a raised to the power 4 plus if we add 1 to both sides, you'll get something like this, and this will be equal to 1 plus b over a whole square equals to 2, which means taking the square root, 1 plus b over a whole square will be equal to square root of 2. Now we're going to take only the positive root because the inside part is positive. If we take minus, it's infeasible because 1 is positive and b over a is positive. Okay, so this is equal to square root of 2. Okay, triangle BAP means 1 plus b over a whole square, which means this is square root of 2. So by all these calculations, what we can say is that triangle BAP, this triangle, has an area of square root of 2. Okay, all right, that's all about this question.